Hi friends, see in last video at current electricity regarding Polycet 2025, we discussed about the synopsis. Okay, we discussed about the synopsis of current electricity in part 1. Now in part 2, we will be doing some numericals regarding Polycet examination. Okay, note down the first one. First numerical, current electricity, numericals. First one, these are very important regarding examination point of view. First question is, see, as given as calculate the charge flowing in a conductor, okay, when current passing for 10 minutes, is, okay, so you have to calculate the charge flowing in the conductor, current passing for 10 minutes is 0.6 amperes. A, B, C, D is given the answers as first one 300 coulombs, next one 360, next one 350, and last one is 400 coulombs. Let us try to solve this problem. Now how to solve such type of it? So this is the basic one I told in the beginning of the concept. Q is equal to IT. Solution. Q is equal to IT. So he is asking you calculate the charge Q. So Q is equal to small q or capital I is given how much? 0.6 amperes. For how much time he is passing? 10 minutes. So 1 minute 60 seconds into 60. This point and 1 0 gets cancelled. How much? 6 6 are 36 and 1 0. 360 coulombs. See where it is? So B is the right answer. Okay? So or otherwise you can put by 10, 0 will be cancelled. 6 6 are 36, 360 coulombs is the answer. So that is the first question, basic question regarding the charge. Let us go to second question. Second question is given as, see here, calculate, second question please. Calculate the specific resistance, rho. Calculate the rho, that is, that's not writing clearly, I will take one more. Calculate rho value, specific resistance of a material. Calculate rho, that is specific resistance of a material wire, rho, if the resistance is 20 ohms. If the resistance of the wire is 20 ohms, diameter is 1 millimeter, and the length of the wire is 3.14 meters. Length of the wire is 3. We have also given the choice also A, B, C, D. First one is 5 into 10 power minus 4 ohm meter, because the rho. 5 into 10 power minus 5 ohm meter. 5 into 10 power minus 6 ohm meter, and D is none. Now let us do the solution for this one. Please note down the question first of all. Second one. So here is asking you calculate the rho value, specific resistance of the material wire. He is given resistance, diameter, okay. Now the solution goes like this. See here. How to solve the second question? We all know in the concept R is equal to rho L by A. Okay. Now we want rho here. Therefore cross multiply. RA by L. RA by L is equal to rho. And he is given the values of resistance how much? He is given RS 20 ohms. Area means wire. If you take, wire is in a circular shape. So pi d square by 4 area, not pi r square, because even if you write pi r square, what is the diameter? Diameter is equal to 2 times radius. So if you put here pi into, in the place of diameter, if you put 2r, see d by 2 is equal to r. So d by 2 whole square. That means what happens? Pi d square by 4 in the place of area. And length is given as how much? 3.14 meters. All are in essay. And diameter is given how much? Diameter is given as 1 mm, I think, isn't it? Yes, 1 mm. So this one you have to convert, please. It is millimeters. So convert into meters. That is 1 into 10 power minus 3 meters. So this is diameter. Now all these values put it here. Resistance how much? 20 ohms. Area pi d square by 4. That is 3.1. That is pi value. Pi d square. D means how much? 1 into 10 power minus 3 meters. Pi d square by 4. Okay. Ra by length. Length how much is given? 3.14 meters. 3.14, 3.14. 4 ones are 4 5s are. So how much you are getting? 5 into, please, 5 into 10 power minus 3 whole square means how much? 10 power minus 6. So answer is 5 into 10 power minus 6 ohm meter. You can check here. This is wrong answer. This is also wrong. And this is right answer. See, 5 into 10 power minus 6 ohm meter. See, this is how you have to calculate the values of the specific resistance. Clear? So that is the solution of the second question. Clear? Please note down. Now let us go to the third one, please. Copied? Right. Now I will write the third question, please. See, if you practice more number of problems, you can score more in the examination. Let us go for the third problem, please. Third one. Third question. I will rub this also because it's completed. Third question. Okay. Now the third question goes like this. See here. Third question. Third question is given in this fashion. See, it is given as calculate the values of individual resistances. Third question, please. Calculate. First, write the question. Calculate the values of individual resistors or resistances. Calculate the values of individual resistors if they are connected first in series, the effective value is, they are connected in series, the effective value is 12 ohms, and if they are connected, in parallel, the effective value means effective value of the resistance was, it seems 2 ohms. Okay, this was the question and it was called, given the choice also A, B, C, D. It is given as 2 ohms, 6 ohms, 3 ohms, 6 ohms, 6 ohms, 9 ohms, and D, 2 ohms, 4 ohms. Now let us see the solution for this one. This is a little twisting question. You have to do properly by using little basic mathematics algebra. Calculate the value of individual resistors if they are connected first in series. The value was 12, and if they are connected in parallel, value was 12. See, for in this case, first we have to let the two values are R1, R2. Let the two values be R1, R2. When they are connected in series means what is the effective value? Re is equal to R1 plus R2. That is equal to how much is given? 12 ohms. So R1 plus R2, 12 ohms. Equation 1. And if they are connected in parallel means what is the formula? R1 R2 by R1 plus R2, which is equal to what? 2 ohms. Let it be equation 2. Now let us play a small game. R1 R2 is equal to, what is R1 plus R2? Is given 12. So 12 into 2, that is R1 R2 is equal to how much? 24 ohms. Clear? Now we have R1 R2. You have to find out R1 minus R2. So in mathematics, you know one formula algebra. R1 minus R2 is equal to root over R1 plus R2 whole square minus 4 R1 R2 algebra. Therefore, R1 minus R2. R1 minus R2 is equal to root over R1 plus R2 whole square means how much? 12 whole square minus 4 into R1 R2. What is R1 R2? 12 2s are 24. So finally this is going like this. 12 12s are 144 minus 96 root. So 144 minus 96 how much? 8. 13 means 40. Is it right? Please check it. 12 12s are 144 96. Did I give the correct value? Please check it. Because you are not getting root here. 14 8. 13 4 48. Please check it once. You are given the right values or not. They are connected in series 9. Oh yes, you have done a wrong one here. If they are connected in series here, we have written as 12 ohms. It is not 12. 9 ohms please. 9 ohms. Effective value was 9 it seems. So please change that one small correction. It is not 12. That's why you have not got the value please. Please correct that one. Okay. Please correct that one please. Okay. So when we are connected in series, it is 9 ohms, 2 ohms. Now we are getting it. R1 minus R2 is equal to root over R1 plus R2. That means 9 whole square minus 4 into R1 R2. What is R1 R2 value? R1 R2 means from this how much you will get here? R1 R2 is equal to R1 plus R2 into 2. That is 9 to how much? 18 ohms. Therefore 4 into 18. So this happens to be 81 minus 72 root, that is nothing but root 9, and that is equal to plus or minus 3. Minus cannot be entertained here, only positive values are taken. So 3 is the value R1 minus R2. So R1 minus R2 is equal to 3 ohms. Okay. R1 minus R2 is equal to 3 ohms. And R1 plus R2 how much you are given? R1 plus R2 is equal to 9 ohms. So when you add up, 2R1 is equal to 12. R1 is equal to 6 ohms. So you can see R1 we got 6 ohms. So R2 how much will be getting? Put it in this equation. R1 6 plus R2 is equal to 9, or R2 is equal to 9 minus 6, that is 3 ohms. So 6 ohms comma 3 ohms. Okay. So because here this cannot be, you can see this also cannot be 6 and 9, this also. So the only answer is here 3 ohms and 6 ohms. Okay, this can be the answer. Okay, R1 is, how much you got? R1 is 6 ohms, because he has written in a reverse manner R1 R2, but you can take it as granted. 6 and 3 are the answers. R1 is 6 and R2 is 3 ohms please. Please note down the solution. This is little twisted problem please, third one. Okay, right. Can I rub it? Now let us go to the fourth problem in our series of current electricity in the second video. Okay, right. Now let us go to the fourth problem please, fourth one. Okay, now in fourth problem, see here, is given as, yes, is asking you to calculate the heat energy, calculate the heat energy released by an element, carrying a current of 3 amperes, carrying a current of 3 amperes, whose resistance is 5 ohms for 1 hour please, for 1 hour. Calculate the heat energy released by an element carrying a current of 3 amperes when a resistance whose resistance is 5 ohms for 1 hour. So he has given answers also A, B, C and D. Is given as 162 joules, B 162 kilojoules, C 160 joules and 160 kilojoules. So this is the problem regarding heating element form, that is H is equal to I square R2 or Q is equal to I square RT. Already I told you in the first video. H is equal to I square RT, heat released, and please make a note it is in joules only because you already calculated in joules already in the concept. So heat energy means H is given by I. How much I is passing current? 3 amperes. So 3 square. How much resistance is given? 5 ohms. 1 hour time is given. 1 hour means 60 minutes and 1 minute 60 seconds. So finally if you calculate 3 these are 9 into 5 into 6 into 6 into this is 100, 10 square. So how much are you getting? 9 5s are 45 into 36, 6 5 30, 0, 3 6 4 24, 27, 3 5 are 15, 5 is 12, 13. Is that the right one or you have done any values or taken any wrong values? 3 amperes I square. Okay. Yes. Anyhow, we are getting. So finally what happened? 0, 12, 1, 6. Yes, right. So 1620, okay, into 10 square is there, that is 100. So finally we got it as 16230 joules, please, SI unit. But here if you observe the answer, some are given in joules and some are in kilojoules. So what I will do is divide with 1000. 3 zeros, 3 zeros. So answer is 162 kilojoules. 162 joules. Wrong one. 162 kilojoules is the right answer. Please note down. Okay. So this is how we have to carry on the problem with heating effect, please. Okay, fourth one. Now let us go to fifth one. Fifth numerical in current heating. Note it down, please. Right. Now let us go to fifth problem, please. Let us go to fifth problem. Fifth one. Fifth problem. Now in this fifth problem you have observed, he is given as 1 kilowatt hour. 1 kilowatt hour is equal to dash joules. A, B, C, D. Okay? Is given as 36 into 10 power 5. A. B is given as 36 into 10 power 6. 36 into 10 power 7. 36 into 10 power 8. See, already I calculated this one for you in the before concept. 1 kilowatt means 1000 watts. 1 hour means 60 minutes. 1 minute means 60 seconds. Okay. So 1, 2, 3, 4, 5. 6 is a 36. 36 into 10 power 5 and joules. Because watt into second is nothing but work. So joules. You can see, you can take first answer. Remaining all are wrong answers. If you put point here, this may become right answer because 3.6 into 10% is also right. So this will be the right answer. A. Fifth question. Okay. Please note down. Let us go to sixth one. Sixth question. Sixth question, please. Of current electricity is asking you the resistance of an ideal voltmeter is. The resistance of an ideal, I told you ideal is an imaginary one. The resistance of an ideal voltmeter is dash. A 0, B infinity, C both A and B, D none. Already in the theoretical subject I told you in this chapter, the resistance of an ideal voltmeter. See, Generally, in general, voltmeter means, I told you this is the symbol. In an external circuit, always it is connected in parallel. Always it is connected in parallel. And an ideal voltmeter resistance is infinity, please. So B is the answer. B is the answer, not 0. Okay, and not both A and B. Only it is B, not A and B, please. It cannot be 0 and infinity. For ideal resistance of voltmeter is infinity, please. Next one, and make a note, it is always connected in parallel with the external circuit. Seventh one. Seventh question, please. These all are very, very important. What all questions I am dealing now? Seventh one. The resistance of an ideal ammeter. The resistance of an ideal ammeter is dash. A, B, C, D. A, infinity. B, 0. C, both A and B. D, none. This is also concept I told you. Ammeter is always connected in series, please, not in parallel. Therefore, the ideal is taken as 0 here. B answer, 0. For an ammeter, ideal resistance is 0, please. Okay? Any doubts? Right, let us go to the next one. These bits are very, very important in the examination. That is 8th one. 8th question or 8th problem. 8th one. Okay. Let us go to 8th question, please. So in 8th question is given as, see here, is asking you calculate the, please note down, calculate the potential difference. 8th question, please. Calculate the PD, potential difference across a resistor. Calculate the potential difference across a resistor which is having 5 ohms resistance, okay, 5 ohms resistance for each second, okay. So is asking you potential difference in each second 5 ohms. You can see, calculate the potential difference across the resistor which is having 5 ohms, okay, for every second. And I think he has given, yes, he has given heat energy also, I think. Yes, he has given heat, and that means what he has given is calculate the potential difference across a resistor which is having 5 ohms, and the heat energy is 150 joules. He has given heat energy emitted for every second. Each second is 150 joules. Okay, so 150 joules of heat energy is produced per second, okay, for each second, who is having 5 ohm resistance. Is asking you potential difference. Very, very easy one. He has given choice also, A, B, C, D. First write the choice, then I'll give you the solution, how to solve it. He has given answers as 27 volts, next 27.35 volts, 27.4 volts, and a D 28 volts. Now let us try to solve this one. Okay, solution. I'll rub the 7th one. See here, solution please for the 8th one. Solution. Now already I have given an equation for you in the concept in the first video. Heat energy H is equal to I square RT, and he is given H value how much? 150 joules is equal to I square, I don't know current, resistance is given 5. For every second he told time, that means 1 second. So from this you can calculate current value by how many times? 30s. So I is equal to root 30. So root 30 means nearly you will be getting around 5.47 if you calculate. 5.47 nearly. Okay. 5 as a 20 something nearly 5.47 current value. Now he is asking you potential difference PD. So what is potential difference? Apply your Ohm's law. V is equal to IR. V is equal to IR. So I is, you got it as 5.47 into resistance 5 ohms already given. 5 7 is 35, 5 3, 5 is 20, 23 3 2, 5 is 25, 26, 27, 1 2 decimal. 27.35 there, yes, B answer. Remaining all are wrong answers. 27.35 volts is the potential difference of that whatever circuit. Okay, clear? Please note down. Note down please. Right. Now let us go to the next problem. Ninth one. Ninth question please. Ninth question. Ninth question. See these numericals, what are problems I'm telling you, you have to practice for the examination so that you will get full marks. Physics 40 out of 40 if you try hard. Next one is ninth problem. Ninth problem, what is saying is, what is the SI unit of electrical power? What is the SI unit of electrical power? Dash A, B, C, D. He is given choice also. First one is he has given as watts, B, joules, C, newtons, D, none. See, joules means it is unit of work, newtons means unit of force, watt or kilowatts is the unit of electrical power or power. So A is the answer please. A. Ninth one. Okay. It's a very small one. Let us go to 10th problem please. 10th question. 10th one. See, it's a little lengthy problem but still write down. 4 ohms, comma, 6 ohms, comma, 8 ohms. 3 resistors are first connected in series. 3 resistors first connected in series and then they are connected in parallel. So these resistors are first connected in series and then are connected in parallel. Calculate the ratio of resistance in series to that of parallel. Calculate the ratio of effective resistance value in series to that of parallel. Is given answers also. Please write down. Is given choice A, B, C, D. First one is given as 33.2:1, 33.2:1, 1:33, and C 32:1, and D 1:32. Little twisting problem but very easy one if you try it. Let us do the solution now. Solution. Now in such cases already I told you, here is saying that first is connected in series. What is the formula for series? R1 plus R2 plus R3. Solution. So R1 plus R2 means what is the RE value in series? 4 plus 6 plus 8. That is 18 ohms. The same way is connected in effective that parallel connection. That means 1 by RE is 1 by R1 plus 1 by R2 plus 1 by R3. LCM if you take 4, 6 and 8, how much you can take? 24. 4, 6 are, 6 4s are, 8 3s are, 10 plus 3, 13. 13 by 24. But I want RE value. Effective and parallel. Reverse reciprocal. 24 by 13 ohms. Now he's asking you the ratio. Ratio of RE series to that of RE parallel. How much you got? 18 ohm series by parallel. 24 by 13. That is equal to 18 into 13 by 24. 6 3s are 6 4s are 13 3s are 39 by 4. That means 4. How much you will get? 33 is 39 by 4. Okay. Please check it once. Is that the value? 468. Okay. 24 by 13 reciprocal. 18 into 13 by 24. Yes, because whatever value got, 13 by 24 is 1 by RE. But I want RE value, cross multiply. See, this value is 1 by RE is equal to 13 by 24, isn't it? Cross multiply. 13 RE is equal to 24, RE is 24 by 13. So, series to parallel means 18 by 24 by 13. That means 18 into 13 by 6 3, 6 4, so 13 is 39 by 4. 4 8s are 4 9s are 36. How much is left out? 3 is left out. 36 3. 0.47s are 24. See, 9. I think answers, wrong answers are given. Please try to correct the answers, please. Little answers were wrong. Okay. So we got actually 9.75 is to 1. We got. Take the answers like this, please. 9.75 is to 1. 1 is to 9.75. 8.75 is to 1. 1 is to 8.75. Please, sorry for that one. Here, I think some answers were wrong. Answers were given. I have corrected the answers here. So this is the answer. The resistance in series to parallel. 9.75 is to 1 you got, please. Okay, so A is the answer. Not 1 is to, because 1 is to is parallel to series. But he is asking you series to parallel. Please note down. Okay. Right. Copied? Yes. Now let us go to 11th one in our series, please. 11th one. 11th question, please. 11th one is asking you as here. He has given a small circuit. That is 2 ohms, 4 ohms, 6 ohms. Now he is asking you what is the effective resistance value. In this figure, effective resistance value A, B, C, D. He is asking you effective resistance value, please. And the answers were 2 ohms it seems A, 1 ohm B, and C 3 ohms, and a D none. Now how to solve this one? Already I told you in the chapters. These two are in series. So what is the effective as R1 plus R? That means 6 ohms. And these two are parallel with this one. So what is the formula for parallel? R1 R2 by R1 plus R2. 6 6 are 36 by 12. 12 3s are. So C is the answer. 3 ohms. Okay. So this is how you have to solve. We have to go a little faster so that you can get the subject properly. So this is how you have to solve. Because easy one you have to go faster. If it is a tough one, it will go slower. That is regarding 11th one, please. Shall I go to 12th problem now? Please note down. Next 12th one, please. 12th problem, please. Now 12th one is asking you calculate 12th one, calculate the strength of current. Calculate the strength of, that means I value. Strength of current if 10 coulombs of charge is flowing in a conductor for 5 minutes. for 5 minutes. For 5 minutes, please. Okay? And he has given the choice as A, B, C, D as 0.1, 0.1, 0.3 amperes, of course, 0.2 and 0.5. 0.2 amperes and 0.5. So solution is very easy here. Use the formula Q is equal to IT. Already I told you in the beginning of the chapter regarding concept. Q is equal to IT. Clear all of you? Now here apply the formula. Charge is already given, the charge 10 coulombs. You are asking you to calculate current I into time for how much? 5 minutes. 5 into 60 seconds, because 1 minute is equal to 60. 0, 0. So I is equal to 1 by 5. That is equal to 0.2 amperes. C is the answer, please. Very easy one. Okay. So this is how. Clear? Shall we go to the next one? Please note down. Right. 13th one. 13th problem. See, in 13th problem, he is given like this little twisting problem. He is given a circuit. He is given a circuit, 2 ohms, 4 ohms connected with a battery, having voltage 6 volts. Okay, he is asking you, he is given a circuit. He is asking you what is I1, I2. Okay, he has given the answers also. I1 3 amperes in first case, 3 amperes comma 1.5 amperes. B 2 amperes 1 ampere, 2 ampere 1 ampere B, and C of course 3.5 4 amperes, 3.5 and 4 amperes, and last one none. Last one none. First one 3 amperes and 1.5. Second one B 2 amperes 1 ampere. C 3.5 amperes and 4 amperes, and D none. Now this one is a very easy one. Already I told you in parallel connections. Parallel connection, what happens? Current is distributed. You can see here I is coming total current. Here I1 and here is I2. And V is constant, please. I distribute. That means whatever I is going is distributed as I1 plus I2 solution. And 6 volts, whatever thing is constant for both. So first what we will do is we will calculate total current by using Ohm's law. So, and what is the effective resistance also, because 2 are there, parallel connection. What is the effective resistance? Parallel connection means R1 R2 by R1 plus R2, 6. 2 1s are, 2 3s are. So 4 by 3 ohms is the effective resistance. Total current means Ohm's law, V is equal to I into effective resistance, 4 by 3. 2 3s are, 2 2s are, 3 3s are, 9 by 2. That is equal to I. Total current means 4.5 M. Total current how much is going here inside? 4.5. This 4.5 is distributed in this and this as I1 and I2. But we know in parallel connection what is constant? PD is constant. Whatever PD is here, same PD. So calculate PD at the top. What is PD here in this box? I into R. That means I1 into 2, whatever PD is equal to same PD here. That is I2 into 4. 2 1s are, 2 2s are. So I1 is equal to 2I2. I1 is equal to 2I2. But what is I? I1 plus I2. But our total current already got 4.5. So 4.5 is equal to I1, 2I2. 2I2 plus I2. So 4.5 is equal to 2I2 plus I2, how much? 3I2. So 3 1s are, 3 1.5s are. So I2 is equal to 1.5 amperes. I got I2 here, you can see, nowhere answers. So I2 1.5 means certainly the A will be answered, because what is I1? We have the equation already. I is equal to I1 plus I2. And what is I? 4.5 is equal to I1 plus I2. I got it as 1.5. Take it to this side. 4.5 minus 1.5, that is 3 amperes. So I1 is 3 amperes, I2 is equal to 1.5. Clear? So that is about the story of 13th problem. Please note down. Clear? Okay. Now let us go to the 14th in our version. Little twisting problems. Now I am entering into twisting. 14th one, please. We will go for some standard questions. Okay, these are also important. What all told I just now. Now let us go to the 14th one, please. I am rubbing this one. 14th question. Okay, let us go to the 14th question, please. Now, see here, very important questions. These are asked regular in the examination. Now, a piece of wire having resistance R. See, a piece of wire having a resistance R is cut into 5 parts, 5 equal parts. Then these are connected in parallel. Okay, if the equivalent resistance of this combination is, if the equivalent resistance of this combination is R dash, then the value of R by R dash, is dash. A, B, C, D. So he is saying a piece of wire is having resistance R is cut into 5 equal parts. Then they are connected in parallel. If their equal resistance is equal to R dash, what is the value of original by cutting part R dash? Now such type of problem you have to go like this. Solution also, yes, he has given the values also choice. First of all, write down for your practice 1 by 25, 1 by 5, 5, 25. Now see how to solve such type of problem. Typical problem it is. Now a wire is there, its resistance is R. Now it is cut into 5 equal parts. 1, 2, 3, 4, 5. See, 1, 2, 3, 4, 5. So when resistance R is cut into 5 equal parts, then each resistance how much it will be having? R by 5. Each resistance will be R because each are equally cut, not unequally. And they are joined in parallel. So what is the effective resistance in parallel? 1 by R1 plus 1 by R2, 1 by R3, R4, R5. So 1 by RE means 1 by R1. What is the first one resistance? R by 5. Plus 1 by R by 5. How many times? Like 5 times. So 1 by R by 5 means how much? 5 by R. Plus 5 by R. Plus 5 by R. Plus 5 by R. 3, 4 plus 5 by R. This is equal to 1 by R. Are you following the question here? So 1 by resistance, because this is the value. This is each value. So 1 by of that thing means 5 by R. So how many times? 5 by R, 5 by R, 5 by 5 times. That means 5 by R into 5. Even if you add also, take LCM R. Ones are 5, 5, 5, 5, 25. So 5 5s are 25 by R. But this is equal to what? Effective resistance 1 by RE is equal to 25 by R. So what is RE value? Reciprocal. R by 25. But it is asking you what is the value of R by R dash. Original value was R. R dash means effective value in the parallel connection. How much? R by 25. R by 25. That is equal to R into 25 by R. R cancelled. 25. See where is the answer? D. Are you following? So these type of problems, little twisting problems. Now here he asks you, they are connected in parallel. Suppose if he asks you in series, the answer may be different. Series, can you try for series? Next question you can try for series as a practice. See, because he is connected in parallel, I got it as how much? 25. First of all, note down this one. If it is connected series also, we can calculate. Please note down. That you can take it as 15th problem, in other words. Okay, see here. Now same thing, same problem. If you are connected in series, what happens we'll see. How the answer will change we'll see. That one you can take it as a 15th problem. 15th one. Same thing, suppose if they are connected in series, that means R by 5 is the resistance of one value, R by 5, effective value, R by 5, R by 5. Are you following? Because each value is R by 5. R by 5, R by 5, R by 5, R by how much? 3, 4, 5. R by 5. So when you are connected in series, how many times? You can take the LCM here. 5 times. See, R by 5, R by how many times? 5 times. So R by 5 into 5. So what is the value? R, isn't it? Or if you are confused, take LCM, in other words. 5 is the LCM. 5 ones are 5. 1 plus R. 1. 1 into R. How many? 5R. So how many times? 3, 4, 5. 5R by 5. How much R you are getting? So what is the effective value when series? R. Now he is asking you what is the ratio of initial to series. So initial was R and also in series was R. R cancel how much? 1. So suppose if these are connected in series, the ratio happens to be 1. Because he is asking you they are connected in parallel, the ratio is 25 here. So as a practice, we can do this also. Clear? And that will be 15th one. Now let us go to 16th problem. Let us go to the 16th problem, please. Okay, clear? Right. In 16th problem, 16th one is asking you, please, which of the following terms does not represent electrical power? Or you can say like this, what is the power, electrical power formula? Electrical power formula. A. P is equal to VI. B. Okay. Next one is, so he is asking you what is the electrical power formula. P is equal to VI. P is equal to V by I. C. P is equal to IR. D. P is equal to I by V. So he is given 4 formulas here. What is the electrical power formula? P is equal to VI, P is equal to V by I, P is equal to IR, P is equal to I by V. See, all these are wrong answers. 3. P is equal to VA. And one more you are having V square by R. One more you are having I square R. So these 3 formulas are representing electrical power. These are the wrong answers. For the confusion is given V by I, IR. This is not V, IR. IR means it's Ohm's law. Okay? Right. Now let us go to 17th one, please. 17th problem, please. Are you following? 17th one, please. Now in 17th problem is asking you can see here. 17th one. See here. A 12-volt battery. A 12-volt battery is connected. A 12-volt battery is connected across an unknown resistance across an unknown resistor. A 12 volt battery is connected across an unknown resistor, and there is a current of 2.5 amperes, milliamperes in the circuit. Find the value of the unknown resistor. Find the value of the unknown resistor. Okay. So he has given a 12 volt battery is connected to an unknown resistor. Then the current is, it seems, 2.5 milliamperes. He is asking you find the value of the resistor. Okay. So for this one solution, so he has given what all he has given. Voltage is given 12 volts. Current is given how much? 2.5 milliamperes. That means how much? 2.5 into 10 power minus 3 milli. Micro means 10 power minus 6. Now he is asking you the value of R. So simply apply Ohm's law. V is equal to IR. So 12 is equal to I. 2.5 into 10 power minus 3 into R, unknown resistance. So now what happens? 12 by 2.5 into 10 power minus 3 is equal to R. Take this point, put it to the top, and 5 5s are 5 24s are. Okay, see here. 5 5s are 25, 5 2s are 10, 5 4s are 20. So 24, take 10 to the minus to the top plus 3. 2400. How much you got? 24,000 ohms. And is also given choice also. I forgot to give A, B, C, D. Is given choice also. 240 ohms, 2,400 ohms, C, 24,000 ohms, D, none. So what was the answer we got? 24,000. So C is the answer, please. I forgot to give the choice, please. Choice also given. 240, 2,400, 24,000 and none. This is a very simple problem. By using Ohm's law you can calculate. The 17th problem, please. Please note down. Clear? So we go to the 18th one. 18th problem. Okay. Now 18th problem, please note down. Okay. He is given an electrical bulb. An electrical bulb is rated 220 volts and 100 watt power. 220 volts and 100 watt power. Now, when it is operated on 110 volts, the power will be dash. Okay, it is given some answers also. A, B, C, D. He has given 100 watts, 75 watts, 50 watts, 25 watts. Okay, so an electrical bulb is rated at 220 watts for a power of this thing. Now I'll rub this one so that it can be easily solved. Are you following the questions here? Very, very important questions. What all you have done from last 30 minutes or 40 minutes? No? So how to solve this problem? Solution. So here is given what? First voltage is given 220 volts, power is given 100 volts. So when the voltage is this much, power is this much. And he is asking you when the voltage is 110, what is power? So we have some formulas also, I think, regarding voltage. P is equal to V square by R. Isn't it? We have some formula. P is equal to V square by R. Power is equal to V square by R. Now what we'll do is we'll try to calculate, because here he has given 110 voltage and we don't know their resistance value. So we'll try to, from this one, we'll try to calculate resistance. P is equal to VI. Okay. Yes, we'll try to calculate resistance by using this formula. We'll try to calculate. We'll see what happens. Or else you can also use by using power formula P is equal to VI, and we can calculate current also. By using power is equal to VI, by using this formula you can calculate current. Then also you can calculate the power. Okay? Right. Anyhow, we'll use first this formula. Power is equal to VA. That means 100 is equal to 220 into I, 0, that is 10 by 22 is equal to I. 5 2s are, 5 5s are, that is 2 by 5 amperes is equal to current. Now he is asking you what is the power when the voltage is 110. So power is equal to VI. Again, power is equal to VI, that is equal to 110 into I, how much I got? 2 by 5 current. So 5 1s are, 5 22s are, 2 2s are 4 and 2 2s are 4. Is that the answer? You are getting 44 watts. So otherwise we will go for a different method. If you are not getting, see whether the cancelling is done in the proper way. 2 5s are 10. Yes, we are done here. Small mistake we are done here. See here. That's why you are not getting. Here how much? P is equal to VA, isn't it? So 100 by V, how much you are given, please? P is equal to VA, 100 is equal to 220 is given, please. So 0, 0, 2 5s are, 2 11s are, please. 2 11s are. So while cancelling you have to be very careful. Okay? So I is 5 by 11. 5 by 11 amperes is equal to I. Now we'll try this one. Now here power means again VI. So 110 into I, 5 by 11. So 11 1s are, 11 10s are. So 5 into 10, 50 watts. You can see here. C is the answer. Okay. So be careful while cancelling. You can use your different formulas are there. Depending upon the requirement, you can apply the formulas. So here you have done a small mistake. Here not 25, please. 220 is given. So P is equal to, from that I have got current I value. And that current value I can put it here. P is equal to again VI. Clear? So this is how you can solve very simply. 50 watts is the answer. 50 watts is the answer. So you can see here power, and this thing is power P is equal to VA. Power may be directly proportional to voltage. Okay. So more voltage, more power. 220, 100. And here what happened? Power how much you got? 50. 50 we got. So thereby voltage also dropped again. So P you can take it as directly proportional. P is equal to VA. Okay. So let us go to the next one, 19th one. Another 2 problems left over for you. With that we will complete all the problems. 19th one. 19th one. Note down. We are coming to end of this chapter. See here. Very very interesting question. How many 176 ohms resistors, how many 176 ohms resistors, okay, how many 176 ohms resistors, I mean in parallel are required to carry 5 amperes current on a 220 volt line. Okay. Now he is asking you how many 176 ohms resistors? That means how many that means same equal values. 176 ohms, how many means values are same value. That means each value is 170. How many are required to connect it in parallel to give carry a current of 5 amperes on a voltage? So here you know what is the effective resistance in parallel? 1 by R1 plus 1 by R2, 1 by R3, so on. So here 1 by RE effective is equal to 1 by R. 1 by R. So here what is the value here? All the values, suppose for instance take this value as R. For instance, forget about the value. For instance take this 176 as R. So 1 by R plus 1 by R plus we don't know, let it be N resistors. Let us assume as N. So 1 by RE is equal to 1 by R, 1 by R, 1 by R. How many times? N times. So N by R. So from this what is effective value? Effective value R is equal to reciprocal R by N. Okay? So effective value is R by N. But R value is given as 176. So 176 by N is the effective value in parallel connection. Now what is given? 220 voltage is given. 220 V is equal to current is also given. 5 V is equal to IR into resistance value. Effective value, that is 176 by N. So from this you can get N value, isn't it? So N is equal to 5 into 176 by 220. 5 ones are 5 44s are. Okay? 44 ones are 4s are. 4 4s are 16 plus 1 17. So N is equal to how much? 4. So how many resistors are required to connect in parallel? 4 resistors, please. Please note down. Very, very important one. It's a regular question asked. Now the last one to end up this chapter. Last problem, please. Last problem. Okay. Okay, clear? Last one I am telling you. Right. Can I rub this one? Yes, last one. Last one, 20th one. Now in this problem, see, is given calculate the value of I if voltage is given as 220 volts over a resistance of 10 kilo ohms. Or resistance of 10 kilo ohms. So this is the question. How will solve this one? Simple and very simple this one. V is equal to IR, Ohm's law. So V means 220 is equal to I don't know, I, you have to calculate, into R is 10 kilo ohms. 10 kilo means 10 into 1 kilo ohm is 1000 ohms. Okay, so therefore 220 by this thing, how many? 1, 2, 3, 4. 10 to the power of 4. Okay? Or I'll write down like this. 1, 2, 3, 4. 1, 2, 3, 4. That is equal to I. So 0, 0. So finally how much you got? 2 11s are, 2 5s are, 0, 0. So finally I got 11 by 500. So you can divide this one if you want it, or otherwise you can simplify this one. See, 11 by 5 right there, and 10 power minus 2. 11 by 5 can do it. 5 2s are 10, isn't it? 5 2s are 10. Point. 5 2s are 10. Point. Again 5 2s are 10. So 2.2 into 10 power minus 2. 2.2 into 10 power minus 2. What is this one? Amperes current. So this is how you can solve the current value. And he has given answers also A, B, C, D. One is 2.1 into 10 power minus 2. B. 2.2 into 10 power minus 3. C. 2.2 into 10 power minus 4. D. 2.2 into 10 power minus 2. So you got already 2.2 into 10 power minus 2 amperes. So this is how you will be calculating, please. Clear? So simply I have used V is equal to IR Ohm's law and finally calculate. Clear all of you? So these 20 problems, I believe that it is enough for you for current electricity practice. So in the first video I told you about concept, second video complete numericals here. So prepare well so that you can get full 10 marks from this chapter. Again we'll meet in the next chapter, please.